Hey class, here's that video I said I'd make you on navigation. So I grabbed a problem here and I'm fine with it, but it doesn't give the angles the way that we're going to give them. And I figured I'd leave this part in where I kind of talk about this for a second to just kind of remind you how this goes. So this notation of N66W, you would, actually I don't know how you read that. North 66 west, I don't know, 66 degrees west of north is usually how I read it, which feels backwards, but that's how you'd read it. So anyway, what does that mean? It means start like you're going to go north, but rotate 66 degrees west of that. So it's sort of the opposite of what we would normally do for a heading. Our headings would always be rotations east from north, right? Or clockwise is how I'd often talk about it. You just rotate clockwise from north. But that means that this 66 degree thing as a heading would actually be what? Well, if we're coming around this way, then the heading that's associated with this particular notation is 360 minus the 66, so 294. So I'm going to go ahead and change that on a bearing of, and maybe that's finally the actual difference between a heading and a bearing. I don't know. Nobody ever explained that to me super well. I think maybe a bearing is maybe more generic than a heading. Maybe a bearing can be explained sort of however you want to, but headings are always east of north. And I could just be making that up. Anyway, when you guys take your quiz, you're not going to get any of this north of west or crap like that. You're just going to get a regular old thing. So let's pretend that said 294. Now the other one, there's a second airplane in this problem that flies on a bearing of south 26 west, or 26 degrees west of south. What does that mean? It means you'd start pointed south and you'd rotate 26 degrees west of that. So what's that for a heading? Well, that would just be 180 plus the 26. So anyway, maybe hopefully you can tell why I'm leaving this in as an exercise. It's a nice little exercise to just be thinking about how to get from one little acute angle to a heading. Because that's how we do these problems after all, right? Is we find just little baby angles at a time. And then we recognize that it's either 360 minus, or it's 270 plus, or whatever it is. So hearing that I think is important. So what is this guy? We just decided it would just be 180 plus, so that would be 206. So we'll make that change too, and then we'll do the problem from scratch. Why am I not making the pen bigger to scribble this out? I don't know. I'm just not. Get over it. 206. Alright, so this is now the problem that we're going to solve. So this is also the part where you hit pause, because you should really do this yourself, not just watch me do it. Really, really, seriously, draw this yourself. Draw it nicely, draw it neatly, and then see if you can't come up with the answer. Now what does it say? How far apart are the planes? So we're going to do more than that, of course, by the way. How far apart are the planes is just part A. But there's a secret part B that also needs to know a heading. Two airplanes even over so what's the heading? Well, plane. I don't know who A and B. A and B are the first and second. Will plane B take to get to plane A? Alright, whatever, let's do this. I don't know how easy this is going to be for me to do with just a weird stylus, so let me go ahead and just make my little north, south, east, west thing that I love so much. Certainly got to have that. I'm going to need a few of these. Or am I? Two airplanes leave an airport at the same time on different runways. One flies on a bearing of 294. All right, what's that look like? I think we just said a bearing of 294 will always start north, but then it'll rotate this way. So here's 90 degrees, 180 degrees, 270 degrees. So I need to go, what, 24 degrees past that? So this looks okay. Again, if you're eyeballing stuff, then the line that bisects 90 is 45, obviously. Half of that would be about 20. So for 20, that looks pretty good to me. Boop, I'll leave that right there. Now the second plane, plane B, is on a heading of 206, which means that you'll start pointed north and you'll rotate 90, 180. To get to 206, we're just going to go 26 degrees more beyond the y-axis, right? 26. So that too should be a relatively small angle. Now I'm not paying a ton of attention to the lengths here, but I should. So the first plane was 325. See how it says 325? So if this guy is 325, then ours at 300 should be basically the same length, but a little shorter. Maybe like here, right? None of this matters all that much this time through, because it's pretty obvious that the red plane is going to be further west. The blue plane will be further east. So as long as you're looking okay, you're going to be fine. So there, I like this. This is fine. Drawing little baby arrows. All right, so now you know that the first thing you want to find is the distance between the two planes, which is going to be here in green. It's not my favorite color, green. I can do better than that. We got to find that distance. And to find that distance, you know that you're always going to do it by law of cosines. And you're going to do it by law of cosines because you know that that first plane traveled 325 miles per hour. Okay, so the whole 2 hour thing again. So it's not 325, it's 650. And the other plane was traveling at 300 miles per hour, but again, doubled, so 600. And then the other thing we always need to be able to find is the angle opposite from the side we're trying to find, or the angle that lies between the sides that we know. But we know these angles. We know these little tiny acute angles here, and we know them from the way we plotted our headings, remember. The 294 degree heading was that 270 rotation plus an extra 24. So we can mark that as 24. I want to zoom in on this too, by the way. So, more. This is going to be too much. Yeah, it might be too much. Nah, it's all right. All right, so again, I'm talking about this little angle here. We said that's 24. And the other one, I don't remember, was 206. So that was 26 degrees past the y-axis. So this was 26. Now notice I don't care about the 26 because I don't care about the angle formed by the blue and the gray. I want the angle formed by the red and the blue. So that means we actually want to use the fact that east, west, and north, south are perpendicular. So these two angles together would be 90. So if you find the complement of 26, if you do 90 minus 26, you get 64. So that piece there in lighter blue is 64. So that means the angle that we care about, the angle that actually goes between the red and the blue, so I shall make it purple for chromatic reasons. That's what, 88? 88 again. It's 88 in the practice problem from the packet. All right, it's 88. 88's fine. Sounds good. So we can find our distance now. We'll find it using law of cosines. This again is that part that all of you guys at least tell me you can do. Now's your chance to prove that you can actually do it. So here we go. Law of cosines says do c squared equals a squared plus b squared minus 2ab times the cosine of c, which is going to be our distance squared, which will be, and it's annoying that these numbers are so big, but that's what calculators are for. So 650 squared minus 2 times 600 times 650 times the cosine of 88. Cosine of 88. Yeah, all right. All right, so I don't have my calculator ready. Give me a second and I'll set that up. Okay, there's the calculator. Again, you can just type this thing straight into the calculator. So this should be the easy part. We're going to go 600 squared plus 650 squared minus 2 times 600 times 650 times cosine of 88. And then just hit enter and you get that number. And then just take the square root of that. So raise that to the power of 0.5. So I'm getting 869 point blah blah blah. Let me see if I can do this. Alright, so I do think it's worth it to you to give me what d squared is. Give me that sort of partial answer along the way. That will let me know that maybe the only mistake you made was in part of your calculation. You're more likely to get partial credit. I would write down the 755,000 number just to have a little more work shown. 3926. And then you can tell me that the distance between them is 869.068. These regular miles are nautical miles, regular miles. All right. Again, this should really be the easy part. The hard part, I think, is usually this second part where they actually ask you to find a heading. So if you're paying attention, you know that I'm calling this guy down here the second one. He's the second one. This one's A. So I'm saying what heading would get plane B to point A at this moment. So to do that, you'd have to reestablish your north, south, east, west again down here at B. And it wouldn't kill you to maybe just draw what you're looking for. So the heading that takes B to A is clearly going to be this angle. That seems to be about 330 maybe, something like that, right? So how do we find this? Well, we know some stuff about the blue line already. We know we know that the blue line has this 26 degree angle. I think I probably care about that more than the 64. And so if I zoom way in on this again, then we can see that by alternate interior angles. You know what? Let me do this first. You've got angle 1, 2, 3, 4. I wish I could make my pen smaller, but I can't. But out of all those angles, I hope it's clear to you that the angle we really want is angle 1, because then our heading is going to be 270 plus angle 1. I suppose if we had angle 2, that would be good too, because of course then our heading would be 360 minus angle 2. Okay, but we need angle 1 or we need angle 2. What we've got though is angle 3, because it's equal to the 26. So this angle here that's formed by the vertical line and the blue plane is 26. What can we do now? We can find the angle formed by the green and the blue. Yeah, and green and blue come together to make what? Brown. Dirty brown. I got dirty brown. So we can find this angle. Because if we can find this angle, then we could subtract 26 from it. Then we'd have angle 2. Once we have angle 2, we have our heading. So there's sort of 3 angles involved here. There's angle, I guess we could call it angle B, right? It's the angle formed at plane B, in the actual triangle formed from the green and the blue. We've got the 26 degree angle, and then we've got the heading we actually care about. So I often talk about maybe the heading can be theta, but along the way we have to find, I don't know, it's angle 1 that I want really. I don't know, angle 2 is fine. Call that phi. So if we want to find theta, we need to find phi, but if you want to find phi, you have to find angle B, and if you want angle B, then you got to do law of sines. So let's do that. So for law of sines, what do we got? We already know the 88 and side D. Remember, we found side D. So we can say that the sine of 88 divided by 869 point blah 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 is going to be equal to the 650 divided by the sine of angle B. So in that way we're going to get angle B. Shrink. Move to the side. Take away calculator. Okay, so we got room to work again. And like I said, we're going to do law of sines. So it's going to be sine somebody over somebody equals sine of somebody over somebody else. That's better. And so again, we're going to use these purple things. We're going to use the 88 and side D. So 88 is going to go in here. Side D is 869.068. Then, because we're interested in angle B down here, we're going to use the 650-mile long side, and we're going to use it to solve for the measure of angle B. And we're going to do this all by cross multiplying, of course. So I say cross multiply. Hopefully by now you all know that I really mean that we're just going to multiply both sides by 650. So this side gets a 650 in its numerator. On this side, the 650 cancels out. Then, to actually solve for angle B, we have to take the inverse sine of both sides. That'll get the sine to go away, and we'll just have plain old B over here. And over here we'll have the inverse sine of this whole expression, meaning the 650 sine 88 all over 869.068. So yeah, these expressions are complicated, but you can do it, and you've got a calculator to do it, so it's no big deal. So that calculator that I just got rid of, we'll bring that back, and we'll do this calculation. And again, remember, the side length that you need is going to be the last thing in your calculator that you calculated, so take advantage of that. We're going to go inverse sine, and we're going to do the inverse sine of 650 times the sine of 88, close parentheses only once, and divide that by our previous answer. So you can hit second answer. You can also just use the up arrow to highlight things that you want. But anyway, close parentheses, enter. All right, I'm getting 48.372. So what does that mean? That means all of angle B is 48.372. But I want phi. So to get phi, we're going to do the 48.372 minus the 26. Oh, clicking on the wrong thing. Okay, so 22.372 is now the part that I really care about. That's the angle I'm calling phi, or the angle that I'm calling number 2. And hopefully from there it's clear to everyone that the heading that we want is a full 360 minus that. So just do that. Oh, I keep clicking on the wrong thing. 360 minus our angle called phi. This guy. So that's the answer in my book. The heading that will take plane B to the location of plane A is 337.628. So you want to write something about the heading, which is equal to theta, is going to be equal to 360 minus phi, which is equal to, I never wrote down phi, did I? Ugh. Ugh. These problems, too much crap. All right, so phi is the 48.372 minus the 26, which gave us 22.372. And so now to get our heading, we're going to do 360 minus that and get 337. 628. All right, and for those of you guys who, like, I don't know, you think you're smarter than me or something, so you don't show all the work that I show, cut that out. Like, I'm not showing all this work just because I want to. Like, this is the amount of work that you are required to show on your assessment. If you show less than this, then you're gonna lose points because I'm going to assume that you just cheated off your neighbor to get to this final answer. Like, I'm sure you could get to this answer in your head, but don't. You need to leave me a trail of your cognition. I want to know what you were thinking. So show this stuff or expect to not get full credit. All right, I did it. I did an example like I said I would. It is 8:44, which means I have 15 minutes to do another one since I said I would do two. And then hopefully I could hastily get this thing posted. But I do have another problem for you. So, those links. All right, so remember, for this problem, it was the classic two planes leave from the same place kind of problem. So one plane went sort of northwesterly, the other one went southwesterly. I think this is sort of the easier thing. So let's do the other kind of problem. This one, the kind of problem where one airplane travels on a certain heading and then something happens. There's a thunderstorm or something, or a mountain that it has to fly around. So it has to change course and go a different way. Those ones I think are a little bit harder. But let's give it a whirl. Again, if you're all feeling great about how you got the last one right, then try this one. Hit the pause button, draw yourself a picture, do the math, and see if you get the same answers as me. So, where's my little north, south, east, west guy? I want him back. Come here, old friend. Okay, so grab me a little north, south, east, west guy. It says we're traveling on a bearing of 200. So 200 would be 180 and then 20 more. 20 is a popular angle. All right, so that's going to be southwest-ish. So that means I could probably put my guy over here to the right a bit, knowing that my plane's going to travel to the left a bit. I've got plenty of room. I like this little ray drawing tool. This thing's nice. So again, just to model this, 200 means you're starting from due north and you rotate through 90 degrees, 90 more, and then 20 more. So roughly here. Seems good to me. Okay, now we're going to change. Well, actually, I should mark the length of that. That was a 1500. And I should mark the angle as well as being 20. And the anal retentive among us are going to want it all to be red. Except for this. Shoot. Although, I like that black background. We're going to stick with that. Which means the north, south, east, west stuff will be white. All right, so what happens now? Now we do it all again. The plane has to change directions, which means you want to reestablish what north, south, east, west looks like. And draw the next little leg of the trip in neon green. All right, and it's 250. So 250, you could think of a couple of ways. 250. All right, whatever. I'm annoyed by 250 because 250 is 20 degrees shy of 270, which means both of these little baby angles are 20 degrees. I don't love that, but I'm not going to change it at this point, I don't think. So this little guy is 20 because they're alternate interiors. This guy's also 20, That's just kind of bad luck. I'd like for those numbers to have been different, but it shouldn't really matter. I don't think it doesn't make the problem like a lot easier, so who cares? It travels an additional 500. So how's 500 compared to 1500? It's a third. Does mine look like it's a third? Not so much. Um, Again, it's not the most important thing in the world to be exactly 1/3 as long, um, but I do find that the more accurate you are, the better. Yeah, I'll try not to go nuts here, but that looks like a reasonably drawn 20 degrees. This looks reasonable as 1/3 of this. So I'm happy with this drawing, except for this fact that it's overall pretty small. So what happens if I try to make it bigger? Everything goes haywire, of course. Take its picture. Make the picture bigger. All right, again, nothing matters. This is all fine. All right, what do we know? We know a couple of things. We know that on the second leg of the trip, we have another 20-degree angle. And we know that this distance is only 500. Okay, great. So what do we have to do? Probably the same thing, right? From here, we pretty much always want to know how far are we from the starting point and what heading would we have to take to get back. With this kind of problem, often, maybe something's wrong with the plane, so it flies home itself. That's one heading. Another thing that could happen is maybe there's a second plane here that flies to the distressed plane. So the heading from port to the ship, or the heading from the ship back to the port, that's obviously going to be two different headings. It is in your best interest to know how to find both, so think about that. And again, this problem is only asking how far is the plane from the starting point, but you know that we definitely want to solve the other thing. What are the headings from ship to port, port to ship? And when I say ship, I mean airplane to airport. I'm thinking about boats again. Ship to port, port to ship. Okay, so what are we doing to find the distance? We're clearly after this blue line segment. And we're going to find that blue line segment the same way we found the other one. We're going to use law of cosines. And to do law of cosines to find this here distance, we're going to need this here big old obtuse angle, which we already said is 20. And then this other guy is also 20. And the guy in the middle is obviously 90. So we know that this big obtuse angle is 90 plus 20 plus 20, aka 130. So if you wanted to, you could just kind of redraw this thing kind of sloppily. Label this thing as 130. Label the sides as 1500. Label this side as 500. And hopefully from there, it's clear now. Without all this clutter, you can see that we just have a side angle side problem. So let's solve it. I'm going to skip some of these steps here and just cut to the chase. We know that c squared is going to be the 1500 squared plus 500 squared minus 2 times 1500 times 500 minus 2, oops, super psych, times cosine of 130. That's d squared. So again, do all this in your calculator. There we go. So I want to do 1500 squared plus 500 squared minus thinking about something. Maybe I'll tell you, maybe I won't. cosine 130. All right, 15.5, 15.5. Yeah, it looks fine. So it's a big number. Just take the square root of it. That's a big number too, but you expected that because one of the sides was already 1500. So you know you're going to get something greater than 1500. So 1861, 231 it is. 1861, 231. Miles? Miles. All right, again, I super don't really care about this. I feel like most of y'all are getting that right 100% of the time. It's the heading part that I'm concerned about. So how do we do this? Well, you're going to need another north, south, east, west line drawn from the airplane's current location. And hopefully you can see that the heading we're after is just this little acute angle here. So how do I find that little acute angle? I don't know. You would want to find the angle formed by the blue and the green. Remember, the blue and the green is not the 20. That's the other thing that I see kids psych themselves out on. Is they've got this thing that's labeled 20, and then your diagram starts to get so tight because you kids draw things so small, like you're trying to save the earth, like by saving 5 square inches of paper. Like, come on, don't worry about it. But the 20 is here, right? The 20 should be neatly tucked in here. But somebody's going to come back to their work and be like, oh, 20, awesome, I already know that this is 20. Well, no, it isn't. You just mislabeled it. So be careful. We have to find that other guy. So I am going to get rid of that one. It's a little big. Make room for what we actually want. What we actually want to be finding is this angle here between the blue and the green. Let's refer to that angle as, oh, I don't know, how about phi? Because our heading is going to want to be, oh, I don't know, how about theta? So there's a lot of angles floating around here. And don't forget the other angle that we totally know already, which is the 20-degree angle that's located over here. So by alternate interior angles, we know that the green and a horizontal make 20. So the green and a horizontal down here make 20. Do I care? Do I care? Yeah, of course I care. All right, so our first step is to actually find phi, which is the angle located inside the triangle. And you guys remember how to do that, right? It's going to be law of sines. So we're going to want to do the sine of the 1500